So in the last class we were talking about the DO. Today let's carry forward our discussion here. Today we'll talk about the advantages of using this DO pattern. Yeah, data access object, the DO. So the advantages of using this DO pattern, first of all, it enables transparency. How, you see, now as I told you people, this DOs will be used by business objects or any other data clients, I can say. Data clients means the objects, which take the help of the DO to, to interact with the database server to fetch the records or update the records, whatever it is. Because they need the data which is in the database server. So generally we call them as data clients. Okay, yes, the DOs will help them in that regard. So business objects or any other data clients here, you see, I can say that you can use the data source. Okay, business objects can use the data source. Data source means your database without knowing the specific details of the data source implementation here. You see, the DO completely DO provides abstraction over the data source. So only DOs will be aware of the database. The rest of the application will not have any idea about the database, with which database server they are supposed to interact with, and all such details are not needed for the rest of the application, right? They're completely concealed or hidden. So you see, only DO will be interacting with the database, right? It provides a complete abstraction of the database. Yes, it provides complete abstraction over the data source. Okay, you see, access is transparent because implementation details are hidden inside the DO. Next, it enables easier migration also. You see, because now the data access code is not spread across the application, it is only in the DOs, right? So, for suppose if you have to migrate to a different database server, you need to migrate to a different database server. So then what you will do here, it would be easy for us. That is what it says. Enables easier migration. You see, a layer of DOs makes it easier for an application to migrate to a different database implementation. Yes. So the business objects have no knowledge of underlying data implementation. you'll find that the business objects here, they don't have any idea about the underlying data implementation. Yes. So if you have to switch to a different database server, it won't be that difficult for you people, right? Yeah, I'll show you in the code. Let's check this in the code once. Yeah, hi Martin. So we are talking about the advantages of using the DO.
Hi.
So the ID is opening. Meanwhile, let me just tell you this. So you see, so business objects which use this DOs, you see, they can interact with the database server without having any details about the database or data source, right? Because the data access code is in the database, or sorry, in the DOs. Data access code is actually in the DOs. So data source code is in the DOs, in the interactions. So the rest of the application will not have any idea or any details about the data source. The DO provides a complete abstraction over the data source, means the database here, you can say. So, next, here, see the access is completely transparent, right? Because the DO, it hides this data source details from the rest of the application. They don't have any idea about it. Yes. Next, you see, as the next advantage is enables easier migration here. So, so that means it would be easy to migrate from one data source to another data source because you see here the code is not spread across the application, right? The code is not spread across the data access code is not spread across the application. So we only have the details about the data source in the data access code in the DOs. So if you have to make any changes, then what you will do here, you will go to this DO. Sorry. So where exactly you have to make the changes? If you want to connect to a different database server, so what you will do, only in the DOs first, in the base DO you'll make changes. This is the connection code, right? Where you have specified the data source details. Here you will make the changes first of all. Here you will make the changes, and at most you might need to change this query slightly, the syntax of it. So as I told you people earlier, the syntax of SQL, it will vary from database server to database server. Syntax of SQL will slightly change from database server to database server. So here you might need to change few things here in the data source as well. Yes. So you see, the rest of the application, it won't be, it need not worry about any migration here, right? Yes. It need not worry about this migration stuff. Yeah, it won't have any idea about it. In fact, it may not know about it. Yes, fine. So hope these 2 points are clear for you people, right? Any questions in this figure? If it's clear, let's move on. Okay, so let's move on. So you see, it reduces complexity in the business objects. The DOs will help us to reduce the complexity in the business objects. How it will reduce the complexity in the business objects? See, because DOs manage all the data access complexities. You see, it simplifies the code in the business objects and other data clients that use DOs. So all implementation related code is, which is related to the data access. You see, all such code will be in the DOs. It is contained in the DOs, right? Not in the business objects. So this improves code readability and development productivity. Yes. As we have discussed in the last class, you see, business objects. Business objects means the objects, uh, in which you got business logic. Business logic means the code which which implements business rules of an application. Business logic means the code which implements business rules of an application, right? That is business logic. You see, as part of executing the business logic, this business objects, they may need to interact with the database server. They may need to interact with the database server. For example, we have considered order processing. To process an order request, okay, so here this application needs the product details, the quantity in the inventory. Let's say a client has placed a request, sorry, a customer has placed a request or placed an order. Customer has placed an order for a particular item, and that customer wants 20 items or 20 products. Okay, yeah, the quantity is 20. The order which is placed for this product is the order quantity is 20. You see, in order to process this order which is placed for a particular product whose quantity is 20, the customer wants 20 numbers of that particular product. So now the application has to check whether this quantity is available or not. Yes, in the inventory. Only if that quantity is available in the inventory, then only this order request can be processed. Otherwise, it cannot be processed, right? So where will be this quantity details in the inventory, which is in the database server again. So the inventory details, uh, what is the quantity of a particular product? All such details will be in the database server. So the application has to fetch these details from the database server. Okay, check the available quantity in the inventory, where the details are stored in the database server. It has to fetch those details and then further process the request. So if you to process this request, order processing, it needs to interact with the database server, the business object, so which implements this rules of processing in order, right? So, but you see, if you develop a business object by adding the business logic and also the DB interaction code in the business object itself, then it would be difficult. What happens that object becomes complicated. In even you see as a developer who is writing this code, it would be difficult for them because you have the data access code as well as the you know business logic. Everything is in the business object itself, right? So you see, if you separate this code, you will have an advantage, right? So what is the advantage if you separate this code? Now, as a developer who's developing the business objects, they can just concentrate on the with implementing the business logic itself. So they don't need to worry about DB interactions here. They don't need to worry about DB interactions. Yes. Who will take care of this DB interactions? The data access object will take care of it, right? So that is one of the advantages, you see, reduces code complexity in business objects. Yes, it will reduce the code complexity. Yes. Okay, and you see this code also, the business object, the logic which you have written, the business logic which you have written in the business object, it will be more readable, right? So because we don't have logics mixed up here, okay, we have separation of concerns. Here we'll have only business rules implemented in the business object. Data access code is in the data access objects. It would be easy to read the code, maintain the code also. Yes. Next we see here centralizes all data access in the separate layer. Yes. You see, in the last class we did develop a DO, and you will find that this DO, it it in that DO you have the code to only interact with one to fetch the records from only product table. Okay, only from the product table you have to fetch the record. For suppose if you want to work with other tables, then you'll accordingly create another DO. Okay, right? If you have customers table to work with customer records, you create another table. So this way you may have several DOs, each working with a particular entity type, I can say. So all these DOs will have the data access code in it, right? So you see, all the DOs, they form a layer. Okay, so just above the DOs, you'll have business objects, and they will be using this DOs. And DOs, you see, they're on top of your database, right? Yes. Here, it provides a separate layer, and this layer, DO layer, will be responsible to interact with the database. So the DO layer will be responsible to interact with the database server, right? Yeah. See, that is what we have. Because all data access operations are now delegated to DOs, separate data access layer can be used as a separate data access layer can be used as a layer that can isolate the rest of the application from the data access implementation. Yes. This centralization makes the application easier to maintain and manage. Yes, of course. Now it would be easier to maintain and manage because we have that logic, data access code, complete data access code is in a separate layer itself, which only deals with database server. So of course, generally we call it as a data access layer. It is actually called as data access layer, or we say persistence layer. The term which is used here for this layer where you have all the DOs, it is called as persistence layer. So above the persistence layer, you'll have the business layer. Okay, business layer where you have all this business logic. Okay, where you have all this business logic, I can say. Yes. So this way, separation of concerns. You see, every layer will be responsible for a specific or it plays a specific role here, I can say. So this helps us to organize the code in a better way. Okay, so that is another advantage of using the DOs. Yes. So is it clear for everyone? So any questions in this regard? Okay, good. So that is about your DO. Okay, yes. Now, as I told you people today, I'll be talking about stored procedures, not in detail, but to some extent, I'll do it so that at least you know what is what. Sorry. So, what are stored procedures? Yes, I'll show you how to call stored procedures also. Stored procedure. So, what is a stored procedure? Okay, no idea. What that is.
A
So,
stored procedures a set of sequence.
set of okay sequence. Yes, yes. You see, a stored procedure is a group of SQL statements that form a logical unit. It's a group of SQL statements which forms a logical unit and perform a particular task. They are used to encapsulate set of operations or queries to execute on databases. You can think of them as set of operations or queries to execute it on a database. So, for example, you see operations on employee database could be coded as stored procedure executed by application code. Yes. So hire an employee, promote an employee, look up or search for an employee. Maybe you may have several criteria to do this. Yes. Which might not be possible using a single query. So, for example, now let me show you people a sample stored procedure. Let's see how it looks like. Let's see a sample stored procedure. You see, so when you talk about this sample stored procedure, and this is how you will create a procedure also. You got the complete procedure here. So first of all, let me just tell you what this stored procedure does. What is the functionality which you got here? You see, this stored procedure, it reads a product price, and it will check whether it will check the price of that product. Then it displays a message. It will store a message based on the price. If the price is greater than 50,000, then it stores a message called as price is taxable. Else, it stores a message price is not taxable. That's it. That is what you will see. So that is what it does. The stored procedure. You see, the stored procedures, you can think of them as methods or functions. But what is the difference here? Unlike stored procedures, unlike your methods, unlike the regular Java methods which we saw, the stored procedures, they won't return any value. So the results after the stored procedure is done processing, whatever the results which are generated, they will be stored in a variable. And generally we call it as a out variable, I can say. That variable where the results are stored is called as a out variable. Yes. Here, now let's try to understand how to create this stored procedure. So this is in MySQL. You know what? The way you create a stored procedure, it might slightly change from database server to database server again. Okay. So in MySQL database server, so this is how you're going to create a stored procedure. I can say this is how you'll create a stored procedure. So first of all, you'll use this keyword create procedure. Yes, they're predefined. Create procedure followed by the procedure name. What is it? Check tags. Okay, check tags. So the procedure name can be anything. Here I named it as check tags. You see, like methods, the procedures will have names. Like a method, like a method. You see, procedures will have body. For methods, you'll have a body, right? Similarly, for methods, you'll have body. Similarly, you'll find that for the procedures also, you'll have a body. Yes. So here, you see, this procedure which you got here, it takes it got two parameters. If you can check this for this procedure, two parameters are declared. What are these two parameters? One is called as in parameter, the other one is out parameter. Yes. For procedures, generally you'll find that you got something called as in and out parameters. Yes. So what are these in parameters? Here, when I say in parameter, you can think of it as a input parameter, which represents what value this method takes. In this case, we have one in parameter. You see, generally, to define an in parameter, the keyword in is used. To define an in parameter, the keyword in is used. Yes. See the keyword in followed by the parameter name. Parameter name is your wish. You can give any parameter name. In this case, the parameter name is PID. And then followed by the parameter name will specify the parameter type. It is integer type. That means now this in parameter, it represents that this method here, it takes one input parameter. This method here, it takes one input parameter. Yes. Okay. So next, you see, we have one out parameter. The second parameter is called as out parameter. The out parameter means it is actually used to store the results. As I told you people, like methods, the procedures won't return the results. Instead, the results are stored in out parameters. So this out parameter, it is what type here? It is actually no. It's not column name. It's just input value which you need to pass. For the methods, you'll pass some parameters, right? It may take some input. It's not mandatory for the methods also. A method may or may not take any parameter. So similarly, the procedures also, they may take an input value. While calling the procedure, you may need to pass some input. So that input is represented by this in parameter. Okay. I hope everyone got it. What is in parameter? Still, anyone got any doubts? Okay. So next out.
Can we pass multiple input values?
Yeah, there won't be any issues as I told you. Like method may take any number of input parameters. Okay.
But only one output.
There will be one output parameter. Yeah, you can have you can try also using multiple parameters if they should work. Yeah, because unlike your methods, they won't return values now. So the results can be stored in multiple variables and you can read them from the variables. If it has written a value, then it is a problem. But you can have multiple out parameters also. So now the results are just stored in the variables. You can have any number of variables here from where these results can be read. Okay. Now you see, in this case, we have one out parameter. The parameter name is message. As I told the people, it may not be message. You wish you can give any name to this out parameter. And here, you see, the out parameter is varchar type. So varchar. So what is equivalent type for varchar in Java? What is equivalent type for varchar in Java?
String.
String. Yeah. Varchar of 25 is there if you can check this. That means this message variable is of type string. In terms of Java, you can think of it this way. The message variable is of type string which can take 25 characters, set of characters. Okay, it can take 25 characters. That is what it indicates. Yeah. So next, you see, for the store procedure, you'll have a body. For the store procedure, you'll have a body. You see, like methods. So when we talk about the body of a method, the left curly brackets, it represents the beginning of the body, method body, and right curly brackets, it represents the ending of the method body. How about here in store procedure, we don't have any curly brackets, okay, so you won't find anything like that. So instead of curly brackets, you'll see begin and end statements here, if you can check this. Begin and end. This begin, it indicates the beginning of this procedure. And you see we have end keyword here down in line 16. It indicates the ending of this store procedure here. That's it. So this is how, this is the body of your store procedure. Whatever the code you have between this begin and end. Yes. So now what is the code which you got here in the store procedure? Let's read it. So first of all, you got this statement, declare price. Means we are declaring a variable with the name price, and followed by that variable name, we have the data type details again. Float. That means we got a variable called as price, which is of type float. Yes. You know, this is a temporary variable, I can say, which is declared here in this procedure. Just a temporary variable. Next, now in line number 8, we got a select query. If you can check this, select product underscore price means it is a column name which is in the product table. Product underscore price is a column name, so which you'll see in the product table. See, here we have this table with this name product underscore price column. We have a table in which you got this column called as product underscore price. Next, if you select product underscore price, we won't read the value from that column into price. We want to read the value from that column and we want to store it into price variable. So just now, just above the statement, we have declared a variable, price variable, right? So we want to read the value from that column and store that value into the price variable, which is a temporary variable. So from this column is in which table? From product table. We are specifying that column name from product, where we have a condition product underscore id equal to PID. That means from a particular column, so from a particular row whose ID will be provided, from a particular row, whose product ID is provided by the users. From that row, you'll be fetching that, you'll be reading that product price, and you will store it into that variable. So you see where condition, where clause is there. Followed by the where clause, we have the column name. So product underscore ID is a column name, and you see we are specifying that PID. What is PID here? Whatever the value which you have in the PID, we are storing it, we are assigning it to this column. What is PID here? That in parameter, yes, input parameter, or it is called as in parameter, right? Yes. You see, so that product ID will be passed as input to this method, so which will be used to read the product price from that row and will store it into this variable called as price. That's it. That is the query. Okay. So after reading that product price and storing it into the price variable, so what is the next thing we are doing here? We are checking the price. Price is greater than 50,000. If it is greater than 50,000, you see, have you noticed it? In the stored procedures, we can add conditions this way. It is possible. In the stored procedures, you can add conditions definitely. Yes. So we have if constructs, which you can make use of in the stored procedures. The if price is greater than 50,000, then what we want to do here, then we'll assign, you see, we're assigning a value to that message variable. So this message variable is the out parameter. Okay, the message variable is basically an out parameter. So to this message variable, we are trying to assign that value. You see, in stored procedures, unlike your Java, we won't just directly assign the value. If it is Java, you say message equal to some value. But here you see, before this variable name, we are using set keyword. That means whenever you want to assign a value to variable, you use set keyword here. Set message equal to price is flexible. If you want to assign a value to a variable, you use set keyword. Use set keyword. That is what you need to do. Yes. Okay. So you see, if the condition fails, then we have another statement to execute. What is it? Else. Else message equal to price is not taxable. Okay. We'll print a message. Price is not taxable. That is what we'll do. And then you see, to end this if condition, we'll add end if here. Yes. End this if condition, we'll add this end if. Yes. Okay. Now this is a stored procedure. See, it's a logical unit which can contain some functionality in it, right? Yeah. In the stored procedure, as of now, we have only one SQL query. But based on your requirement, you can add multiple SQL queries also. You can have set of SQL queries. Yes, it is possible. So you will find that here we'll store the stored procedures in the database itself. They will be compiled and they are stored in the database server. So whenever you want to execute the stored procedure, you can simply invoke it or you can call the stored procedure. They are stored in the database server. Yes. Once you're done writing a stored procedure, you can compile it and you can save it to the database server itself. Okay. Yes, that is what happens here. You see, already I have the stored procedure in the database server. You see, if you go through the schema under the stored procedures, you'll find a your procedures which you have created. Okay, so you can simply add save the stored procedure here, and you can call it whenever you want. So how will you call the stored procedure? Let's see. See, for example, you take this second product whose ID is 102. The price is 22,000. Okay, let's do this. Call test.product. It takes one in, sorry, test.check tags, which takes one parameter, that is 102 product ID. You can pass any product ID here. Make sure that the product IDs are available. Next, see, we have to declare out variable. What is it? Let's say message. Yes, you need to do this at the rate message. Now, the stored procedure will be invoked, and that input value 102 is passed. And we have the out variable message. We will use at the rate message always here. Yeah. So whatever the value you got, now you'll have it in that variable. Simply, you can read that value from the variable here. Simply, you can read the value from that variable. So how will you read the value now? See, after the stored procedure is executed, you can do this. Select at the rate message. That way. First execute the stored procedure and simply display the value which is stored in the results here. That is what you can do. Fine. Just a minute, please. Yeah, sorry. So let me run this code here. You see, now you got a message that the price is not taxable. That's it. This way, you'll be able to call a stored procedure. Okay, and how will you create a stored procedure? What you will do? You see, if you want to create a stored procedure here in MySQL, okay, you saw the code, but quickly you can use this option. You see, right? You will find the stored procedure section. Right click on it. You have create stored procedure. Okay, it is asking to select the schema. So set this test as the default schema here. Now right click on this stored procedure. You see you'll get the sample code, sample template here. This is the template code for your stored procedure. Now you can write your logic, whatever you want to write. And then what you can do is here, you can actually, once you're done writing the stored procedure, you can click on apply. Okay. So what it does, it will compile that stored procedure. And if it is successfully compiled, then the compiled stored procedure will be stored in this database. That's it. And whenever you want, simply you'll be able to call the stored procedure without any issue. Yes. Okay. So I hope you people got it. Now the question is, how can we call a stored procedure from the database server? We saw how to execute a select query, an update query, insert query, but how will you execute the stored procedures? That is what I would like to show you people. So this is where your JDBC API comes into the picture again. Okay, yes. So earlier, in order to execute a stored procedure, yes, what are the sorry, earlier to execute this SQL queries, okay, we have used a couple of objects. Can you people tell me what are they? We have used a couple of objects to execute the to execute a query. What are the objects which you have used to execute the queries?
A statement and prepared statement.
Yes, statement object and prepared statement object. Now here what you will do is to execute a stored procedure, you will use another object called as callable statement. We will use something called as callable statement here. Yes. So first of all, you know, again to call that stored procedure, we have to establish a connection. Okay. Let's try to establish the connection here first of all. See, why I'm instantiating the base DO, because in the base DO we have a method to establish the connection, right? Yeah. So just I'll call this method to create a connection. The get connection method. So in the declarations here, we'll add this method called base DO dot get connection. So which returns a connection object reference. We'll store it in a reference variable of type connection from the SQL package. Yes. Once you got the connection, Now what you will do, you will call this method called as prepare call and pass that stored procedure call here. Call test.check tags. Here you have to add the question marks, the bind parameters here. Okay, add the bind parameters. So this prepare call method, now it returns the callable statement object. Okay, simply it returns callable statement object, I can say this. And then once you got the callable statement object, see, we can use this callable statement object to execute the procedure here. But before that, we have to assign the value to that bind parameter. The first bind parameter, it represents that input parameter. The second bind parameter, it represents that output parameter. So we have to assign a value to that input parameter, the product ID, right? Yes. Let's access that bind parameter and assign a value to that bind parameter here. Okay. Yes. See, set int index is 1 and the value is, let's say, 103. Next, you see, the second bind parameter is something different. It's not input parameter. It is a out parameter. So because it is an out parameter, we don't have to assign any value. But here, JDBC, it expects us to provide that output parameter type details. Here, we have to register that output parameter. I can say we have to specify what type of value will be stored in that out parameter to JDBC here. To the JDBC, we have to provide those details. So how will you provide those details? So we have another method for that. Okay? Register out parameter indexes to, and we have a class called as types. In the types, we have this details varchar. That's it. This way, we'll specify the out parameter type. What is it? We're saying it is varchar type here. Yes. We're saying varchar type. That's it. And next, we can execute the store procedure. You have to use execute update method. Once it is executed, the results were stored in that out parameter, right? Out parameter is represented by this bind parameter whose index is 2. Now I'll read that value from that out parameter using that index itself. You see, what I'll do is callable statement dot get string and the bind parameter index 2. So the second bind parameter, it represents that out parameter, right? So the results are stored in that out parameter. We'll read it. That's it. Okay. So let's run this code. You see, it says price is not taxable. So is there any price whose ID is greater than 50,000? Let's check once. All are below 50. Okay, no problem. Fine. So this way you can execute a stored procedure from JDBC. Just I want you people to have this information. So what I'll do is I'll give you a sample database schema. I'll add it to that Google Drive and a couple of stored procedures which helps you people to dig into more details of the stored procedures. You can just explore it. So I will be leaving this part to you people. Okay, yes. So this is a schema called as coffee shop. So here for this schema coffee shop, I have couple of stored procedures like get supplier, raise price, which are created from a Java application. Yes, okay, they are created from the Java application. So I want you people to go through this stored procedures, okay, and you will be able to understand it, explore it on your own. Okay, so this is the stored procedure. So it is not formatted properly. Now we have couple of SQL, three queries here, not one. We have three SQL queries here. If you can check this. So one is a select query, second one is update query, and third one is again a select query. Yes. So I want you people to check this once. We have couple of in parameters here, and there is in out parameter. So in out parameter, it acts as both in and out parameter. Yes, you'll have third type of parameters called as in out. So I want you people to just try to work with this query procedures. I'll give you the sample code, Java code also how to call the stored procedures. So I want you to give a try from your side. Okay. Yes. So anyone got any questions in this regard, please let me know. I'll add it to the Google Drive. This schemas and the examples you can just go through that, including the Java code to call the stored procedures. Even you'll have the code to create a stored procedure. Okay, how to create a stored procedure from the Java application and call that stored procedure. That code also you'll find it. I'll share it with you people. You try to create the schema. So I just want you people to make yourself aware of this database schemas, tables, associations, because I'm going to start with Hibernate tomorrow. So just it helps you people. Now Hibernate is built on top of JDBC itself. So functions are similar to stored procedures. Okay, but you will find that functions can return a value, unlike stored procedures. That is the only difference. Like stored procedures, you can also call the functions the similar way. Okay, yeah. So they are almost similar to stored procedures. Because these are database concepts, I want you to check this. And guys, already I shared a link with you people, MySQL tutorials, right? There you will find the details about stored procedures also, and you will find the functions also. You can just go through it. Okay, yeah. So because we have a lot of things to discuss in Java, in UI also, so I'm just leaving this part with people, database concept. Okay. Anyways, again, in Hibernate also, you'll come to know more details about database, like associations, foreign keys, everything I'll be discussing. But this is the part which I want you to work on your own page. Okay. But still, if you have any questions, if you have any queries, you can issues, you can just you know clear them. I'm ready for that. Okay. If you have any issues, you can just clarify them. So I'll be available for you people. Yes. You are talking about with regard to the SQL, Ramon. SQL. Let me share some articles if I have got anything. Yeah, so to just optimize the query set so that they can perform and tuning the queries. Adama is asking about tuning the queries, which is more uh, advanced topics in SQL, where you can write a query which executes faster, with less memory consumption, quick execution. So that way you can tune the queries. Okay. So such things I can't discuss here, but definitely if you are interested, I can share some details or notes with you. People you can go through it. Okay, whenever it is possible, I'll do it if time permits. Yeah. Okay. So I'll do one thing. We'll be starting with Hibernate tomorrow, and we'll meet at our regular time tomorrow. So what will be our regular time? Right? So the regular time is 6 a.m. Indian time, 6 a.m. Indian time, which is 6:30 p.m. Central Time, 7:30 p.m. Eastern Time. Okay? That's it. Thank you all. Bye-bye. Please try to work with this database if you have some time today, so that Hibernate. Okay, anyways, it will take 1 day for you for me to show you people how to interact with Hibernate database using Hibernate. So tomorrow we'll be having an introduction session to Hibernate framework. Then also I'll be introducing Maven tool to you people tomorrow. Okay, fine. Yeah. Sure. Yeah. Sure. Google Drive. I'll add it to this Google Drive here. It's done. Okay. So let's meet tomorrow. Bye bye.